Good morning students. Today we are going to learn about torsional pendulum experiment. Okay, what is the aim of the experiment? Aim of the experiment is to find out the resistive modulus of the given wire. Okay, they are giving some wire, so like this some iron wire, steel wire or copper wire they are giving. So we have to find out a resistive modulus of this particular wire. Okay, so what is the apparatus we required? So I have taken one wire. Okay, so we need here stopwatch. So they are giving you stopwatch and a disc for the experiment is a very important. So disc, and we have take out scale we have, and a screw gauge. This is the screw gauge for the purpose of to find out the radius of this particular wire. Okay, now vernier calipers VC. So I have given here the vernier calipers VC. So I am taking here, this is the vernier calipers to find out this disc diameter. Okay, so by using this vernier calipers I am going to find out the disc diameter. From there I have to take out the radius. Okay, so the radius, and you will keep it here, your two jaws of your vernier calipers, and find out the what is the exact diameter by using these tables. Okay, so here I given the screw gauge table, but vernier calipers is similar. You have main scale reading, head scale reading, and diameter is main scale plus head scale into least count. For you have to find out the least count for all the operators. Similarly, for the screw gauge is the table, pitch scale reading and head scale reading, and the diameter you are getting, the diameter of this wire you are getting, and you have to find out the radius. The students what they are doing, the formula directly they are placing here the diameter value, but you have to place out the radius value. Okay, radius equals to diameter by 2. So all the operators means vernier calipers, screw gauge, you have to find out least count, then you have to find out the small r value. Means in the formula we are going to check out the formula. What is the formula for resistive modulus? Resistive modulus formula eta is equals to G and S. They are taking different notation. Now I am using here, so 4 pi m r square by r power 4, means here mass of the disc, this disc mass we are taking. Okay, by weighing machine you have to take out, it means 1 kg you have 1028 grams like this you have, and r radius of the disc. Now you have to find out by using this vernier calipers. Okay, by using the vernier calipers you have to find out the diameter. Okay, half you do it, then you will get here this radius of this disc radius. Okay, what is the smaller? Smaller is the radius of your wire. Okay, by using the screw gauge you have to find out. See that screw gauge I will take out. By using the screw gauge I will find out the smaller value. Okay, don't confuse with capital R and small r. So once again I will repeat, capital R is the disc radius and the small r is the your wire radius, not diameter. Okay, clear this concept? Okay, now so moment of inertia I equals to mr square. Okay, mr square by 2 I have taken here. So can I write it here in other way also? In moment of inertia terms also we are going to write these equations. Okay, so now I will go for L by T square here, the term. The L by T square I am taking from here in the table. Okay, L by T square. So what is we are taking here? So length. Okay, length of the wire. So where to where, sir? Now I am suspending, suppose using the wire. So this disc I am suspending. Okay, I am suspending like this, right? From here you have the check. This is called check. So check to another check is there where it is suspended. By using the scale we are measuring check to check distance. Means here I have to start and I will take out like this. What is the length you have from here to another check? Okay, so that is small l. I have taken the small l here. That your choice you have to take out. Okay, the simple torsional pendulum I am taking. I am not going to suspend here any weights or any ring. I am not going to suspending. The simple way I am going to explain here. Okay, now here I will count for oscillations when I am going to rotate. Okay, twisting. Okay, now so you are getting that time for oscillations. Okay, trial 1, trial 2 we are doing that. Then you are getting average T, that L by T square you are taking. Okay, clear this concept? Now, so what is here the resistive modulus? Now when I am going to rotate, I will take out here, I suspend the wire, okay. So wire, so majorly we are going to find out the rigidity modulus of this wire, not the disc, okay. Now I am simply rotating like this, means see that my hand is rotating, okay. So now it is going to move like this. What happen when I am going to suspend with wire? So it will going to opposite rotation you will get. When you are trying to rotate, opposite rotation will get. That is rigidity, okay. So angular acceleration you will get, angular acceleration. When I am going to rotate now, so disc I am trying to rotate like this. My hand also it is twisting here. See that twisting, and when I am going to release, okay, it will come back to its position, okay. So this is called oscillation, like a simple harmonic oscillations. How you will get same like circular oscillation also you are getting that, okay. This is called a rigidity, okay. So that is the only you have to find out rigidity modulus, right? Clear this concept now. So generally we have to say in your definitions, okay, shear stress by shear strain, okay, shear stress by shear strain. How you are going to apply? Now applying to rotate this like this, tangential force you are applying, tangential force you are applying, this is called your stress. Now here you will getting here strain, once again it back come, shear stress by strain you will get, okay. This is your general definition of your rigidity modulus, right? Clear now. So I'll show you the experiment. By before that I want to show here that table, that's why I am showing here, and how much value you will get. What is the value you have to get here, the final answer for the rigidity modulus while you are calculating for different length. I am taking that. Suppose here half meter or 1 meter wire I am taking that and suspending with a different lengths I will take out, okay. So I am every time I am going to increase the height of this, and I am going to measure the, so what is the oscillation for 10 oscillations, means the disc will going to move. Suppose I am suspended here, this is the reference point. So when I am going to move, and it will going to come back to its original position, okay, equilibrium position, and move somewhat forward. This is called completely one oscillation, means I am measuring from here, suppose, okay, it will go and it will come back one oscillation, and it will go and come back one oscillations. This is the reference point. 2, like 3, like 4, like 5, then how many? Completely 10 oscillation we are going to counting. For 10 oscillation, trial 1, means by using the stopwatch I am going to calculating for particular length. Suppose I am considering the 30 is a centimeters. Now trial 1 is you will get here 50 centimeters you will get, okay. Can I write it here? So example I am writing here, okay. Suppose I am taking 30 centimeters, I am taking by using the scale, check I am measuring 30 centimeters. Now you will get 55 seconds you will get time for trial 1. Suppose sometimes what is happening, by seeing or counting we are doing the mistake, then I will go for the trial 2. So second time I will get suppose 654 or 53 you will get. Then so capital T you are taking here, capital T you are taking, T1 means 55 plus 54 divided by 2 means this will get here, but average you will get, okay. So now what you have to do for time for one oscillations, this is the average, capital T is. Now one oscillation you required here, this is the average. Can I write it here? A average. Now so this one oscillation means how many? Completely 10 oscillations we are counted here, divided by 10, okay. Can I do it like this? Yeah. So this TA divided by 10 you are taking, this is time period for one oscillations, okay, in here. So then I got here TA, so T value you will get here from here, and the length value what I have taken 30 for some T square you are doing that. This value I substitute here. Now we are already found this R value, M value we got, so radius of your wire you got, and calculate you will get here one rigidity modulus for a particular wire, okay. Suppose it's a steel wire or copper wire or any another wire. Suppose I am going for the steel wire. You have different types of steel wires you have. If you are going for the internet, you will get the value like this. Generally the people are measuring in Newton per meter square, correct? Newton per meter square. You will get like values like 7.58 into 10 power 10 Newton per meter square. Sir, I want to convert in dyne per centimeter square. How are you going to convert in dyne per centimeter square? Okay, 1 Newton equals to, you know that, 10 power 5 dynes. You substitute here, definitely. and your meters, centimeters square, 100 into 100, then 4 zeros and here 10 power 5 zeros you will get 10 power 1, means into, if you are multiplying with 10, definitely you will get this value in dyne per centimeter square. Very easy to convert. Just Newton per meter square to dyne per centimeter square, just you multiply this value with 10, then power will changes, 10 power 10 to 10 power 11 dyne per centimeter square. How you want to change? You can change very easily this unit. Okay, suppose PSI. Okay, so pounds per square inch you have to convert. Why? Because sometimes we are going to calculate in pounds per square inch PSI scale. Then how you are going to convert? Just you have 1 PSI equals to 6894.7 Newton per meter square. Now if you want to convert this PSI value, you multiply with how much? Suppose you got here this Newton per meter square, means you divide like this, means this value divide with 6894.7, you will get here some in this value in PSI, some 11 point something, 11 point into 10 power 6. Yes, definitely you will divide like this. Now what you are getting in pitch scale resistance, same you have some 11 point something 67 into 10 power 6 PSI you are getting, means the same value in PSI. Like if you go for brass, you will get here 3.6 into 10 power 10 Newton meter square. Copper you are going to get so 4.2 10 power 10 Newton meter square. Like this you are going to calculate. Okay, torsional pendulum. We'll go for experiment, then you are getting the clarity about this total table and total values, and how can we use these formulas, and how can we are going to use the screw gauge and vernier calipers. Okay, shall we go for the apparatus? Yeah. Hello students, we'll come to the experimental part of torsional pendulum, right? Now aim of the experiment is, we know that already, to determine the rigidity modulus of this particular wire, and I have shown you already apparatus. Once again I am showing you circular disc, okay, provided with chuck nut. I'll show you what is a circular disc provided with chuck nut. Okay, can I show you that? So this is the apparatus complete. See here, this is the circular disc. Okay, this is the check, downside check. When I am going to suspend this wire, so this is the above check. So this is the above check. At the above check, at center I have placed it. See that wire is I have placed it at center. Okay, it's clear. Now see that this is the one more check. Okay, and now in the apparatus you have like this. So circular disc provided with check. Okay, a torsion pendulum. Now the steel wire I have taken here, copper wire. Okay, now you take out any wire, and the stopwatch. Now I have taken this is stopwatch. I will show you the stopwatch, how to start and how to close this one. Suppose you start from here. Okay, now I will press it here. It will start your stopwatch. Now you want to stop here, press here only. You want to reset, left side hand, left side finger you have to use. Now I am going to press like this, it reset. Okay, start, and same button you have to use for stop and reset. Okay, clear? Next, so I will go for here. Next one is screw gauge. So this is, once again I am showing that this is the screw gauge, correct, to find out the wire radius. Now vernier calipers, this is the vernier calipers. So here we have the vernier calipers. To find out the disc radius, you have to find out by using the vernier calipers. Okay, clear? So these are the apparatus where I have taken. For the calculator you have to use for scientific calculator for the calculations. Okay, the scale to measure the length of your wire, right? Clear? Now can I start the experiment? Now I'll go for the table what it is contained. So now I have taken here in the table, we have taken here length of that, not number of oscillations. I have taken, consider the length of the wire. So the student, one of the student, he's taken length of the wire is 30, 40, 50. Okay, now I'll start with one distance. Okay, I'll show you the how much you are getting trial one time for 10 oscillations. That you have to take out your choice. 20 oscillation you need, 10 oscillation you need. That you have to take out the time for 10 or 20 oscillations. Okay, so now I'll take out here some 30 centimeters. How you take out? Now So I have taken the scale now. So I am placing from the check. See that check starting, I am placing here my scale. Okay, check starting means here it is starting the reading. Now it will go for, now the check end means, so here at this part where my finger shows that from up to you have to take out 30 centimeters. Okay, so now you have to take out this side, both the sides we have the centimeters only you have to take out, not inches. The scale you have different side. Okay, now I will go for, and I will find out here some 42 centimeters are there here up to this check, means downside check 2 and check I am going to measure here some 40 centimeter means, so I will open this check and I will adjust for 40 or 30. Okay, so the student started with 30 centimeters means you have to take out somewhat up. Okay, wire you have extended wire you have here. Now you open this check and you have to take out up to 30 centimeters means here check part, check downside check 2, here you have to take out 30 centimeters. Okay, clear? Now I have taken here, so student is taken here 30 centimeter. Now you go for the oscillations. Okay, now I have taken here 10 oscillations, trial time for 10 oscillation, not for one oscillation is this one oscillation is, this is the one. Okay, here this is the time for one oscillations. So he is written here time for, I am taking here time for 10 oscillations. Now I am writing here time for, so 10 oscillations. Now I will count for 10 oscillations. So how much time you required? I am going to start here. How to start here? First you have to take out what is the precautions. Okay, the wire should be here. Okay, so and here downside also. So center of this check, see that center of this check, center of this check. Okay, downside also center of the check. Now and wire should be straight. See that here how much bend you have. Okay, so what is happening when wire is not straight? You have to straight it by using the cutting blade you have to use, otherwise you use your hand and straight number of times. Okay, a fresh wire you have to take out, so wire should be straight. And so the surface you have to here how it is like this, straight means on the plane x plane you have, it is not like bend like this, it will not going to bend like this. Okay, so oscillation you are not getting proper, means circular oscillation we are doing, we are not going for the simply linear oscillations. Linear oscillation how you are taking your +2 you have some bob is suspended here and you are doing the linear oscillation like this. Okay, but we are not doing here the linear oscillations, we are doing the circular oscillation, just we are rotating like this. Okay, some angle, when I am trying to rotate like this, okay, some angle, some 15 degrees, 20 degrees, okay, up to 180 degrees. So now what is happened, the twist occurred inside the wire. If it is bend here, see that the wire is not proper, it is going to bending like this. Okay, when I am showing that, okay, it's not proper, curved one it is there. So what you are getting the opposite torque, means when you are rotating this torque like this. Okay, now this wire is opposing, correct or not? This wire is opposing. So rigidity you will get here, rigidity you are getting opposing this wire, means torque you are getting in this wire, okay, because of this disc. Okay, so torque is decreasing when you are getting the bendings here. Okay, so wire should be, must be at center of check, and wire should be straight, we will get here for getting the good circular oscillations. Okay, clear this concept? Now I have to start with, now I will going to rotate, keep it your hand here and rotate like the small angle like this and leave it, you are getting oscillations. Okay, now otherwise you will put it hand here and slowly rotate here, slowly rotate, I am twisting my hand and release, you are getting oscillations. Oscillations will not going to damp like this, it is damping. Okay, if it is damping you are not getting proper oscillations, right? Clear? Now what you have to do here, so I will take out slowly angle. Now I have take out one reference point, suppose this line I am taking reference, mark it by using the pen or pencil, I am going to mark it. Okay, so otherwise here you have somebody is marked here on that, see that it is there, mark it is there. Okay, the reference point you have to take out. Okay, now I am trying to rotate here like this, means this will going to move here like this, here I am applying the tangential force I am applying, means tangential stress I am applying, strain you are getting in your wire. Stress by strain is nothing but rigidity modulus. Okay, clear? Now I'll start from here. Okay, this is the reference point I have taken, right? Clearly. Okay, now at constant position, so I'll start here. I'll rotate small angle. Okay, I have rotated now. Now I am releasing. I am not twisting, I am releasing here. Okay, now it doing the oscillation. So some linear oscillations also you are getting. Once again I'll start. Okay, do it number of trials. So if you are getting proper oscillation, then only you start the time. Okay, now I'll start here. I am rotating my hand, finger, and I am going to open it. Now you are getting, it is the oscillations. Now it is oscillations. Now you start from here. Yeah, it is rotating this side. Okay, one oscillation, it will move here and come back. Two oscillation. This is the amplitude. Every time amplitude is decreasing now. Okay, so now frequency is means time period is not depend upon the amplitude. Okay, now so any one you have to start here the clock. Now I will start the clock. Now well it will come. Yeah, I'll start here. So 1. So this is a 2. This is going here. Come back 4. So going here, come back here 6, 5, 6, like a 7. It will go every time. What is happening? Amplitude is decreasing. Correct or not? Okay, when I am touching this finger, my hand, no, you are not getting that damping you are getting. Now I will stop once again, and once again I will clear it. Now I will go for the trials. Okay, number of trials you do it, not a problem. It's a very easy experiment. We are doing only simple torsion pendulum, not you are taking the weights, and we are not going to check out. Okay, I am going to rotate. Okay, rotate some small angle and leave it. Okay, now you are getting that will going to move and come back here. Now I will start here the clock. Now I am going to start here. 1. When you are starting, you are going to count down. 2. Okay, 3. Now it will reach here that mark. I will count it here. 4. Yeah, now reaching the mark. See that this mark it going like this that side and reaching here. 5 and 6 and what is getting? This mark is 7 and 8. Okay, now when I am going to touch my finger this disc, some damping you are getting. Okay, like 10 you are getting. Suppose imagine this is the 10. Stop. So how much? 39 second you will get here. Okay, 39. So the student he got here how much second? 28 second he got. Exactly what you are doing. Now I got here. Okay, some disturbance I have, some damping also we have. They do it properly, he'll get here 28 seconds. This is for trial 1. Sometimes some disturbance will get, so he want to go for the trial 2 also. Now once again stop, once again here this disc, and reset your clock, same height. I am not going to change the height of your wire. Okay, so reset this clock. So I will go for once again, so rotate this angle. Okay, clearly rotate now. So see that clearly you have to rotate. Now use your finger here and rotation, otherwise keep your hand here and slowly you rotate. Okay, now slowly apply the force. Now I am rotating that mark. Now release it. See that. So it rotated and releasing. 1, start the clock. So this is 2. Okay, so 3, this mark, 4 oscillations. Now 5, 6, like this you have to count it 10 oscillations. What is the time you have got? See that what you have to take out K here, this should be, wire should be straight and wire at exactly check, then only you are getting proper oscillations, otherwise it is a damping you are getting. Okay, if you are not oscillating like this, you are oscillating roughly, you are getting how much damping you are getting. See that it is linear oscillations also, it is doing that. It is not oscillations. Okay, simple harmonic motions. Carefully you have to observe. Okay, now so the student he got here, see that nearly same time period he got 28. Then a mean he is taking. Mean you know that. So this is a T1, this is a T2, means trial 1, trial 2. Average is T1 plus T2 by 2. correct or not? T1 by T2 by 2. Now he's taken here average T equals to small t he's considered, so capital T1 plus T2 by 2. Now so this is for your 10 oscillations, suppose he is doing that. Okay, now you need one oscillation, so you divide with 10. Okay, you divide with here 10. Now time for one oscillation, okay, that is called time period. You are saying the time for one oscillation. See that he cut and he is dividing this t what he is getting average, he is divided with 10, then he got here 2.87, correct or not? Average you are getting, he got 28, so dividing with 10, 2.8 he will got. Now t square he is doing, and L by t square is he is doing that. L by means L, how you are getting, L is your 30. Okay, so t square you got 8.25, divide it these two values, then you are getting 3.64. Where you have to substitute here? In this formula you have to substitute in terms of 4 pi or 8 pi. So it is there. If you are dividing with 2 and multiply with 2, you are getting 8. Okay, 8 you will get here. So otherwise you will take out this formula, you will get LT square, you will substitute here. Okay, now I'll show you that how you take out the mass of the disc. So you take out the disc, this disc, and weight here. So it is 1028 or 1000 grams you will get, means 1 kg you will get here. That is your capital M here, capital M. And the radius of the disc. Okay, by using this vernier calipers you have to find out the radius of the disc, means here to here what is the distance. Okay, now here to here it is a diameter, and here to here you have to find out radius. Now you have to find out the radius. He got radius is 6.5. Okay, now mass is 1020. Now he's taken here, and A is a small radius of the wire. By using the screw gauge you have to find out the radius of wire. Okay, radius of the wire, keep it here and find out. So I'll show you that by continuation at last how to find out this radius of the wire. So that wire you have to place out and in this formula, and you have to find out what he is getting the rigidity modulus. He calculated here, and he got the value of nearly 2.29 into 10 power of 10 newtons. Okay, for copper you are getting 3. Okay, this is a copper wire only. Okay, we have taken copper wire only, not steel wire. So that you will get here nearly 2.29, means it's a nearly value you got. Okay, nearly value you got Newton per meter square. Right, clear? This is the way you are changing here the length 40, 50, and he is doing trial 1, trial 2, and similar way he calculated, and he got the different rigidity modulus of this in the calculations. Okay, so nearly same values you are getting here, rigidity modulus, and average it, final value you are getting that. You are take out in he's taken giga. Okay, so he's written in 10 to power 10 Newton per meter square. So why we have to take out this graph, sir? What is the use of this graphs? We have got here L by T square value. Sometimes what they are doing is they are not getting this L by T square from the table, and you have to draw so length versus T square values. Okay, from the table you are getting L value and T square value. Take out the graph, you are getting straight line. You find out the slope. Now slope you are getting L by T square value, correct or not? So slope you are getting L by T square. That L by slope value, L by T square value, substitute here. Then rigidity modulus of the wire, you are getting that. Okay, clear? So this is the experiment about the torsional pendulum.